Modern vehicles are increasingly defined by software. From braking systems to battery management, from steering assistance to autonomous driving, software has become one of the most important elements of automotive development. But developing software for safety-related systems requires much more than simply writing code. ISO 26262, Part 6 defines a structured process for developing safety-related software. It transforms system-level safety requirements into verified software that supports the overall safety concept. In this video, we'll explore the major activities of Part 6 and understand how software contributes to functional safety. Before we examine the individual clauses, let's first understand why software development is so important. Today's vehicles contain millions of lines of software code. Software coordinates sensors, processes information, makes decisions, and controls actuators throughout the vehicle. As software complexity continues to increase, so does the importance of structured software development. Functional safety requires more than correct functionality. It requires software that is systematically designed, verified, and tested. That is exactly what Part 6 provides. To understand this process, let's first look at its overall structure. Part 6 consists of 7 major activities. It begins with general principles for software development. Software safety requirements are then specified. The software architecture is created. Software units are designed and implemented. Individual units are verified. The software is integrated. And finally, the embedded software is tested. Together, these activities create a structured development lifecycle for safety-related software. Let's begin with the foundation of software development. Clause 5 establishes the overall framework for software development. It defines the principles that guide the remaining software engineering activities. Rather than focusing on implementation details, this clause establishes a consistent engineering approach. It ensures that software development aligns with the overall functional safety objectives established earlier in the lifecycle. With this foundation in place, software safety requirements can now be defined. Software development begins by deriving software safety requirements from the system-level technical safety requirements. These requirements define what the software must achieve to support functional safety. Once these requirements have been established, engineers create the software architecture. Major software components are identified, responsibilities are allocated, and interfaces are defined. The software architecture provides the blueprint for all later implementation activities. The next step is transforming this architecture into executable software. After the software architecture has been established, development moves to individual software units. Each unit is designed according to the architecture and software safety requirements. Once the design is complete, implementation begins. Individual software units are developed to perform their intended functionality. This process transforms engineering concepts into executable software. However, writing software is only part of the development process. The next step is confirming that every software unit behaves correctly. Before software units can be integrated into larger software components, they must first be verified. Verification activities provide confidence that each unit behaves as intended. Defects discovered during unit verification are typically much easier and less expensive to correct than defects discovered later. This makes unit verification one of the most important quality gates within the software development lifecycle. Once individual units have been verified, they can be combined into the complete software solution. Individual software units are gradually integrated into larger software components. As integration progresses, interactions between software elements become increasingly important. Verification activities confirm that the integrated software behaves correctly. Finally, embedded software testing evaluates the complete software running within its intended environment. These activities provide confidence that the developed software fulfills its safety-related objectives before system-level integration continues. Now that we've explored the software lifecycle, let's see how Part 6 fits into the overall ISO 26262 framework. Part 6 does not stand alone. It builds upon the technical safety requirements established during system development. It also relies on the hardware platform developed in Part 5. Together, hardware and software create the complete safety-related system. This illustrates one of the key ideas behind ISO 26262. Every life cycle phase builds upon the work completed in previous phases. Before we conclude, let's summarize the most important points. ISO 26262. Part 6 defines the structured development of safety-related software. The process begins with software safety requirements. It continues through software architecture, implementation, and unit verification. Software components are then integrated and verified. Finally, the embedded software is tested within its intended environment. Together, these activities help ensure that software contributes to the overall functional safety of the vehicle. This completes the software development perspective within ISO 26262. If you'd like to explore any of these topics in greater depth, we'll cover many of them in future dedicated videos. If you want to go beyond this introduction to ISO 26262, we offer comprehensive online training programs on our website. These self-paced courses cover functional safety concepts, ISO 26262 requirements, practical implementation approaches, and real-world engineering applications. The focus is not only on understanding the standard, the focus is on applying it effectively in automotive development projects. You can find the link in the video description and also in the pinned comment below. If you found this video helpful, please consider giving it a like and subscribing to the channel. We regularly publish content on functional safety, ISO 26262, ASPICE, ISO 21434, and other engineering standards. Thank you for watching, and we look forward to seeing you in the next video.